gentlemen, now we're going to discuss about the demand planning beyond the constraints of Excel and reducing forecast error by 30% with transparent artificial intelligence. And to present the same, we have Chinmay Narwane, Head of India at Garvis with us. Chinmay is a certified supply chain professional from Epix. He is an experienced solution architect with a demonstrated history of working in a supply chain industry. Over his career, he acquired deep expertise in solution design and solution architecture, requirement analysis, business analysis, demand planning, and inventory management. He is currently working as the engagement manager and head of India at Garvis. Can we have a round of applause for Mr. Chinmay?
Hello everyone. So I'm here to present Garvis, which is a very simple forecasting solution which reduces your forecast error by 30 to 40%. And the main focus of the software is that we don't want to do long implementation cycles. And the other thing which is very important in the current industry is basically a lot of time is spent in doing manual work, right? And the problem with that is the planner has to do a lot of manual work, and then finally that information is not stored anywhere, and everything that the organization does is based on the demand plan. So anything like any changes in the market, right? Currently there are a lot of changes which are happening, and then we have no idea how the demand would change because of that. We have increasing number of distributors, retailers, and supply chains that we are having today, and then nobody has any idea of what has to be done for that. So we created a system which is a Bionic demand planning system, which is not a black box. What we did was created a transparent layer where the planner can actually see and understand what has been done by the AI. So it is not something that there is a number and then somebody has to justify the number. So what are the limitations of manual process? So we have time and people, right? And then there are lack of accuracy and lack of insights. And then the result is loss in revenue because your forecast accuracy is not so good, and a lot of capital is employed and a lot of cost. So the solution is that the planner is in control of the AI to navigate the ocean of data. So this is what we work with. So if you look at this screen here, what we have is the past, and now there are a couple of things happening in the past. So this could be a price change, this could be weather changes, traffic, and then nobody knows what has happened here. So we give the opportunity of history mining to the planner, and then the planner can actually say, okay, this was a price change, and this was a 10% price change versus a 5% price change. Then there was weather change, that's why there was a big demand. And then there was so much traffic, that's why we sold more coffees. And this is reusable knowledge. So the planner does not actually do this every cycle. Once it's fed in the system, the planner only has to validate and then provide the future information of what does he anticipate will happen in the future from the events perspective, or looking at different departments and getting insights into the system. The same information is used, we get the data from the world, and the same information is applied here. So now the planner can again say that, okay, there is going to be a traffic, huge traffic coming up, or there could be price change or indexes changes, and the system will understand and predict the demand. And now I want to explain what Bionication means. So we have a demand planner, and he is in control of what the purpose will model. So Garvis has built all the models with the help of AI, which are very specific only for demand planning. So it is not a data science project that you have to forecast a time series. It also understands what are the complications in supply chain and how can we solve those. And then there is a transparent decision making process. Why? Because if the planner cannot enter inputs which are explainable, can be understood by different departments, then the decision process cannot be transparent. We also show what are the different components of the demand. So there is seasonality, there is trend, there is baseline. So you don't do anything, you still sell something. So that's the baseline. So these are the things which need the transparent decision process. And then there is internal and external data. So we allow internal and external data to come in the system through a process called data wrangling, where we have automated the complete process of implementations, because in the past I have worked with organizations where we were implementing the software for like 6 months, 9 months. So that is something that when we talk about AI and ML, why should we not reduce this time? Because this is the time and cost where the demand planner is already demotivated and like surprised or maybe shocked that, okay, I did something for 6 months and this is a system that I got, but then has no idea what the system does. So that's why we have an evergreen system. The system is implemented in one day because we have automated all the data transformation and all the implementation processes and created a semantic data layer. So the planner can quickly look at the data and understand how is that information relevant to supply chain planning and demand planning. So you don't need a data scientist to understand all the AI models. It's just a layer, a secretary that we created for the planner to understand what's happening. And it's zero implementation. So we also don't charge for implementation because that's where we started, that okay, people are implementing things for a very, very long time, and then finally when they see the results, they might not be happy with it. So why don't you implement on one day and then get the feedback? And it's a baby to the planner, right? He trains the system and he works with it. So the user adoption is also really great. Now we talk about the predictive power. Right, so right now we have shipments, which is the long-term predictive power. Then we have orders, NPI, phase out, phase in profiles. We have sell-in, sell-out data as well. And slowly we can also get sales, events, promotions or indexes, maybe weather forecast, and then sentiments from Twitter or YouTube, how many likes are you getting. So this is how it looks like, and we support all these inputs in the system today. So we start with the shipments because it's not possible to get everything in the system on day one. So the basic thing for demand planning is only 3 things, 3 dimensions: what do you sell, from where do you sell, and to who do you sell. These are the 3 most important information and shipments. Some people say we should forecast shipments, so we do that, but most of the people say, okay, we want to forecast the real demand rather than shipments. We can also use that information to forecast. Then phasing, phase out is something that a planner would do on a regular basis because it comes to the master data. So these are things which are already automated in the system, and the planner can really start from day one to get benefits out of this. I would like to show a sample case of promotions here. So on the screen you can see that there was a big spike here, and then the planner explained that, okay, this was because of a promotion, and it's a very spiky demand, intermittent product, only runs when there is a promotion. A traditional system would forecast this green line for the forecast because it has seen some random numbers in the past, so it will try to smoothen it out and it will put some numbers here. But what the Garvis system does is it actually looks at those promotions and try to keep the peaks where they should be, rather than just smoothening the demand. If you look at the impact of COVID, so this is a very nice example across industries. What we have seen is that there are different impacts of COVID on different industries. So you see, a traditional system would do a red line forecast, but then there was a drop, right? So nobody knew that, okay, there will be this drop. But in the future, this information can be used. So if you apply the second COVID event, second lockdown, then the system understands what's going to happen there because it knew what happened in the past. Now there is another industry, the travel industry, which happened that, okay, it dropped and then it kept like that, right? So no impact of COVID because the business itself changed. Then there is another one where there was some hustle buying, like, so don't know why they purchased that much. So this is some grocery shopping which was done here. So demand grew down and then there was lockdown and then people like purchased like anything. So now this is how the system works. So this is my total demand in the past. Then there was a lockdown, so system learned from it. There was another lockdown, the system again learned from it. And then there is a possibility to see another lockdown in the future. So there is this green line which would be the traditional forecast. that okay, it's always going to happen. Then there is a blue line which is the forecast if there is no lockdown, and then there is this red line which actually understands if the lockdown happens, what will happen. So you can also do this assumption based planning in the system, that you are anticipating an event which has happened in the past, or maybe it might happen in the future also. So you can put a profile on that okay, this is the impact that would happen, and the system will give you two numbers, that okay, if it doesn't happen, what is the forecast that you will have, or what is the demand that you will have, and if it happens, what's going to happen, right? This is a quick overview of one of our customers' business case. So this is how the COVID impact was. So this is a picture from our product. So this is how the COVID impact was actually mapped in the system. So these were the places where COVID happened. This was where COVID happened, and the customer said, okay, this is I feel there will be another event here, and then the system generated this forecast. So there is a testimonial from one of our clients in Europe. Would like to play this for you. It doesn't play. Sorry? Here. Okay. And so this was JDE Coffee in Europe, and we implemented our solution not in one day, but we took around a week or two to implement it, and we implemented it across 4 countries for now, and they're really happy with it, and we did it for no implementation cost and very fast. So they also actually saw how many of the market intelligence data sets are really impacting their business. So they also tested price parity. They also tested how the competitors' pricing affect their promotions, and how the displays work out, and all these things were tested at JDE, and that's how they tested it, and they are currently working with us as a happy customer. And within a span of 1.5 years now, we already have 30 customers, and in India also we are expanding, so we have 2 more customers in India recently. So what does it say as a summary? So we have man and AI and an open architecture where we can get anything we want as a data component, and the result of that is gaining visibility into customers, turning data into insights, and the error reduction of 30 to 40%. We use data mining and demand sensing, which I did not cover here, but yeah, we also have a product which is called demand sensing, which actually looks at the orders and tries to improve the short-term forecast accuracy even further by 30%. The result of this is time. So the planners don't actually have to to do a lot of manual work, and they can reduce their time by 10x, and they can actually rely on the system to do the repetitive tasks for them, because the power of machine is basically the computing power. So now the planner can actually rely on that for the computation power. From the money perspective, you can have 25% less safety stock, and then obviously if you have less safety stock and you're not losing sales, you also increase your revenue by 1 to 3%, and then 20% reduction in trade funds. And then obviously the most important thing is happy planner. So no implementation, day 1 the planner is training the system, and explainability. So it's also helpful for the consensus planning and the SNOP. I think yeah, that's all. Thank you.
Any questions? Can we give the mic?
No, that's fine. No, that's fine.
Yeah. Hi, Chinmay.
My name is
I'm
Tineke Kok, and I'm the Global Business Process Owner for Demand Forecasting in Jacobsdouwer Egberts.
Faces
We've quite a challenge on our forecast accuracy, and we see in benchmarking that we lag.
And how do they overcome that?
Sorry, can you repeat that? Just the video is also played.
So what are the challenges industries faces when they go first time for ML or AI model for demand sensing? And how do they overcome that?
So obviously the first challenge when anything new comes in is understanding it, right? And the habit of not using the new things. So that was the first challenge that we also observe at a lot of our customers. Then the other thing is, do you really trust those things which are happening automatically or the new technologies? So that's the second thing. And the way we overcome it is basically by understanding what's not working out, right? What are the things which the human doesn't like about the AI, and then try to basically what we have also done, right? So we created a Bionic layer which actually explains the human what the machine has done. So it creates a trust between the systems basically, and they can work together towards a common goal.
Thank you.
Thank you. Yeah, okay.
Is my voice audible? Okay.
Yeah.
Hi, I'm Murtaza. I'm from Your Technologies.
Hello.
I have a question. Do we have have you tried any use case within the healthcare or the life science industry? Because that's a typical industry which does not follow the regular market dynamics to a great extent. So how do we, or have you any use case? Yes,
definitely. We have a customer in India, Orthoclinical Diagnostics. So they actually work. So the current scope of the project is Asia. So we also do exports, right? So within India, your demand is consistent, but India exports. So India exports would mean anything, all the small countries around India, and then you also have Singapore, and there are some smaller countries around that, and the dynamics is completely different. The sporadicity of the demand that you get there, the licenses of the governments, how they have to plan different the sales or shipments based on the licenses is very different. So how we did that was looking at some intermittent models, because it's also in spare parts, it's also in healthcare, and then definitely it's also in vaccines. So these are the industries where you'll always see a lot of intermittency and seasonality. Both are not completely related, but somehow we also call intermittency and seasonality same, because if you have a classic flu vaccination, then you'll only sell in a very specific season. So that is also intermittency. So we build very, very specific models to solve these problems. And then we also rely on the planners. So it's just not that the models will do everything. The planners also have to see that, okay, these are the customers which I have, how do they order? Are they ordering because of a reason? So right now the government orders a lot of testings after the COVID, right? So these are the things which they have to keep in mind, and based on that they also have to train the system. So it works hand in hand, that okay, there are two people working together. But yeah, we definitely provide purpose-built models to solve supply chain problems across industries, but then it finally comes down to the intelligence that the human has in better judgment of what's going to happen.
Okay, thank you.
Yeah.
Well, thank you so much, Chinmay sir, for this insightful presentation. We invite Sandeep Satapathy from Tata Steels to felicitate Mr. Chinmay. So can we come in the center, please?
Thank you.